Graph traversals. Our topic is graph traversals. There is two graph traversal, DFS and BFS. Depth first search and breadth first search. Okay, first we are going to see about depth first search. DFS. DFS is similar to pre-order search of a tree. Let's take an example 20, 30 graph 10, 50. Okay, now we are going to write DFS the pre-order way. In a pre-order, first we print that root node and then we traverse to the left or right. Similarly, we take a 20 as a source node for traversing DFS. So 20 we need to print, and next we need to traverse left. There we in a graph there is no left right, so you can take any side. So 20 dragon is 20, so 20 is printed. 40, so we need to traverse up to depth. So for 50 is having any nodes? No, we need to print 50. And next 40 is having another nodes? No. 40, we need to print 40. Next back to 20 and this search to 30 is having 10, so sorry, 30 will not 10, so 10 will print. And next back to 30. Okay, like this the DFS work traversal takes place. We are going to use a stack for this implementation. Some pre-order, so writing wide DFS int v. First remember we are using adjacency matrix, not adjacency list. Okay, next visited array which will contain a 1 if we visit that particular node, or otherwise 0, and that's it. These two are requirement for writing a function, int I and w. Okay, first we need to set where it's pre-order, so root node to be set to visited 1, and it will need to print. Next for all it's 1 2 3, so 3 times 0 I less than size of the adjacent matrix. Adjacent matrix is n cross n matrix, I plus plus. So we need to call recursive function int if a of v, so 20 as a root, so we need to be constant. W need to be vary, so here we wrote I, it's wrong, we need to change to w plus plus. W is equal to 1 and visited of w not equal to 1, so we need to call recursive function DFS of w. It's a stand function. I will explain this, trace this with an example. We trick tree only, it's very useful one. Instead 100 20 40, next 10. I'm going to write adjacent matrix a of how many nodes? It's very large, so tracing this will become now. I will do simple one. A, B, C, D. Okay, A, B, C, D, B, C, D. Okay, now we are going to all the, it's a undirected graph. So A to B there is no, there is edge, and A to C there is an edge. From D no, B to C, B to A there is an edge, B to C there is no edge, 0, and D also. C A there is an edge, B no, and C to D there is an edge, and from D there is no edge, only C is having edge. Okay, now we are going to use this matrix, and we are taking source node as A. So DFS of A. So DFS of A. So it will be visited at a first iteration. It chooses 0. So means A. 0 comma 0, and this visited of 0 is 1. So it halts. So net it's traverse to B. Here W will become 1. W will become 1, and A of 0 1 is equal to 1. Yes, it is equal to 1, and visited of that is also still we not visited B, so it's 0. So this function is true, so it will go call DFS of B. After B, so there is a no A of B of W is equal to 1, so this one will be printed A comma B. The output is like this. Next, after this, it's traverse back to the A, and again it calls A of C, A of 0 comma 2, because there is 1 and visited of C is not equal to 1, so DFS of C. So C is printed, and again it will check D. So D, it will call DFS of D. So D is printed. So there is no other non-visited nodes. So A, B, C, D is the output. Like this DFS work. It's a simple implementation of DFA using recursive function. It will use a stack. This the tree traversal takes place. Let's take a complex one. This tree is 20. So visited. Next 20 again. Next similar 40. These all are trees. I will take a graph, cyclic graph, then the better understanding. So here we took a source node of 30. So there is two childs, 50, 40, and next we are going to 40, 60. So this is a tree representation of a graph. If it gives a tree representation of a graph, with there might be in back edges also, because 40 is having a back edge and 50 back edge. We avoid that all back edges. So further in upcoming videos, how that DFS work with the back edge, you're gonna see.